Hi, welcome back. This is lesson 19.3. It's the next one in our series on different features of object-oriented programming, and this short lesson will deal with polymorphism. In this lesson you'll find out what polymorphism is and how and why it is used by programmers, and we'll finish with the exam question that we looked at last lesson. Polymorphism has a very simple definition. It means that the same command, the same method with the same name has different effects when it's working with different data types or classes. A good example is the plus sign in Python. It means different things if you're working with a numerical or a string variable. So if you use plus to join two numerical values, Python will add the two values together. But if you put it between two string variables, then it will concatenate the two variables to create a larger string. And this is one of the reasons why we can't use plus to join a numerical to a string variable, because it has different meanings with each type of variable. So polymorphism is something that we've definitely come across before. Polymorphism is a feature of object-oriented programming too. In object-oriented programming, if you create a method within a class definition, that method will only work on objects of that particular class. A method that has been defined in one class of objects can't be used in another class of objects. So two methods might have the same name but do different things. So if I'm writing one class of object, I'll create methods, I'll name them. My friend or colleague might be creating another class of objects. He or she might create methods of the same name, but they can't affect the objects of my class definition. So methods only work with objects of the class in which they're created. As usual with some of these more fiddly ideas in programming, the purpose of all this is to protect our programs from unwanted side effects, particularly in the context of team working. Imagine that I was working in a team to create a program to do geometry work. I might create a class called square, a class called triangle, a class called circle. Each one of those classes could have a method to calculate the area of the object. But this method will work in different ways for the different classes. So the area of a circle is calculated in a different way from the area of a triangle, as you will know. This is an example of polymorphism. I might use the same method name, calculate area, but I can be confident that I won't accidentally use the wrong method with my objects because the methods are tied to the class definitions. So, if we're talking about polymorphism in the exam, we would start by explaining what it means that methods only work within the class that they have been defined for. Instances can only be changed using the methods of that class. Methods from other classes can't start altering or affecting objects of a different class. They're separate from each other. This reduces risks and side effects, and it doesn't matter if two programmers in the same team accidentally use the same method name. In fact, it wouldn't even be an accident or a problem because methods are glued, if you like, glued to the class definition in which they're created, and they can only work on objects of that class. So let's go back to that exam question that we were looking at in lesson 19.2, where we have to explain the advantages of encapsulation, polymorphism and inheritance. And this time let's think about the second of those technical terms, polymorphism. So once again, there are 12 marks overall. We wrote a little bit of an answer to get 3 or 4 marks talking about encapsulation. Now let's try and get 3 or 4 marks talking about polymorphism. Here's my checklist. We have to show that we've got understanding, that is to explain the meaning of the technical terms used. We have to apply it to this case, the creation of a mobile phone operating system, and write a short amount on the benefits of polymorphism. Now, we haven't done any programming with this, but I'm hoping that what I've quickly told you about the meaning of polymorphism will help you to write this answer. So pause me now, pause this video and write a 3 or 4 mark answer on polymorphism against those 3 checklist points. And in a moment or two I'll continue with this video and show you an answer that I've put together with a bit of a cheat. I looked at the mark scheme from the exam board. So here's my answer. Once again, I've written the 3 headings: understand, apply, evaluate, but obviously you wouldn't write those in the exam. That's just so that you can see how I'm addressing the 3 checkpoints. So first of all, I say what polymorphism means. An operator or method has different effects when used with instances of different classes. That's just the textbook definition. For example, in the operating system, we might want to delete. There might be a delete command. Deleting a folder or deleting a file are different things, so the same command, delete, would do different things working with 2 different kinds of object. And an evaluation, it means that the operating system would be more useful and flexible, and I would also write that the programmers creating the operating system could work on their own projects without worrying that the methods that they're writing might have unwanted effects with other parts of the program. Okay, so how does that compare to your answer? Are you on track? If not, make a note of this, because if polymorphism comes up in the exam, although the application will be different, this kind of example is the right sort of answer to give. So this lesson we've developed an understanding of what polymorphism is, I hope. We've seen how to apply it to an example and what its advantages are, and then using these skills we've written a short exam question. So here's a programming task for you to practice with this. You could write the geometry program that I was talking about with several classes such as circles and rectangles. The constructor would have to take the appropriate measurements so that it could define, let's say, a circle. All you'd need to tell it is the radius. For a rectangle, the 2 sides, the length of the 2 sides, whatever. So define the geometric shapes. Just do circle and rectangle if you haven't got very much time. And then write a method within each class to calculate and print out the area of the object. And obviously those methods will be different for the 2 types of object. And then, hey presto, you've done a bit of polymorphism. Okay, so there is one final attribute of OOP, which is inheritance, and I'll talk about that in the next lesson. So bye for now.